The notes on lesson 4.4 we're going to go through fairly quickly because you really just need a lot of time to practice it. So in class tomorrow we'll do a lot of practicing and then you'll probably have to go home and work on it a little bit more. But it's writing a function rule. So it's taking given information and then making an equation out of that. The first thing you're going to need to do is identify which one is your independent variable. So identify your independent variable. And remember, that's your x. It's the one that you can plug in and you're going to get a y value from it or an output. And your dependent variable, which is your y. And usually you're going to be given this information in some sort of a table. Other times you're going to be given the information in equations, which you've already been doing a lot of practice with setting up equations. So when you're given a table, you're just going to look for the pattern. Sometimes the patterns are pretty easy to see. Other times they're a little more difficult and you kind of have to play around with them a little bit to try to figure it out. And then when you go to set these up, instead of using a y equals, what I want you to use is f of x or f of n or f of something, some kind of number showing as a function instead of y equals. Go ahead and write these three tables down. Just hit pause, write the tables down. Once you have the tables down, go ahead and hit play, and we'll walk through looking for the patterns on those three tables. So in this case, your dependent variables are your y's, your independent variables are your x's. They've already given them to you. What you're going to do is you're just going to look from 1 to 5, what kind of patterns could I have? And then does that match the same pattern as from 2 to 6? And then does it match the same pattern as 3 to 7? And then 4 to 8. So you're looking for that pattern. So take a look at that, see if you can figure it out. Hopefully you figured out that it's adding 4. And now you're just going to set it up as a function. F of x equals, you take some number, your x, and you add 4 to it. X plus 4. So every y value, there's your y's, equals whatever x is plus 4. Okay, let's look for the pattern in the next one. So 1 to 1, and then 3 to 9. 6 to 36, 9 to 81. And hopefully you found that your pattern was squaring your x. 1 squared is 1, 3 squared is 9, 6 squared is 36, 9 squared is 81. So you go ahead and you set that up the same exact way. F of x equals x squared. And then you check it and make sure it works. So again, when x is 1, 1 squared is 1. When x is 3, 3 squared is 9. X is 6, 6 squared is 36. X is 9, 9 squared is 81. And it all fits the pattern. Okay, let's go ahead and look at the next pattern. So take a minute to look at that. Hit pause, and when you're ready, hit play. So this pattern was a little more difficult because as you're following, you're realizing nothing, just one operation isn't working. But if you notice, 1 squared is 1, so we're off by 1. 3 squared is 9, so we're off by 1. 6 squared is 36, off by 1. 9 squared, 81, off by 1. So we're squaring, But after we square, we're actually adding 1. And now you're going to set that up exactly like you set every other one up. So when x, for this function, when x equals some number, I'm going to take it and square it, and then add 1. And then you can try it. 1 squared is 1, 1 plus 1 is 2. 3 squared, 9, 9 plus 1, 10. 6 squared, 36, 36 plus 1, 37. 9 squared, 81, 81 plus 1, 82. Examples 2 and 3, we're just going to go through some applications, some word problems to help set up functions with word problems. And like I said, you've already been doing a lot of this anyway, but go ahead and hit pause, write this down, and then when you're done writing it, hit play and we'll walk through how to set these up. So when you go to set this up, you have to think about what's happening there. The model of a desktop computer is about 20 times the size of a typical computer. So if a typical computer was, let's say, just make something easy up, like 1 foot wide, then 20 and 1 would be 20, because it's 1 times 20. If it was 2 feet, then it would be 20 times 2, so 40. You can stop and plug in numbers to help you figure it out. Remember, you always want to write these as f of x or f of something equals, and all we're doing is multiplying 20 times whatever that typical computer would be. And that's how you set that up. Now there's a second part to this question. So again, hit pause, write it down, and when you're ready, hit play. Basically what they're asking you to do now is just go ahead and find the actual size of a part of a computer that would be in that scale model. You already have your function rule set up, so all you're going to have to do is plug it in and evaluate with it. It says a space bar is typically 4 3/8 inches long. How long is it in the scale model? So right there, all you have to do is plug 4 3/8 inches in for your n. So when a piece of this computer is a certain size, I'm going to plug it in and I'm going to find what it would be in the scale. So 20 times 4 3/8. Now, I know a lot of you are having a little bit of trouble with mixed numbers, so one of the easiest ways to do this would just to be go ahead and make that an improper fraction. So you end up with 20 over 1 times, remember, 4 times 8 plus 3, which is 35 over your denominator 8. Now from here, I like to keep my numbers smaller whenever I can, and I notice that both of these are even, so I know 2 goes into them, and then when I look a little further, I also notice that 4 goes into both of them. So I'm going to go ahead and do some simplifying here, and I'm going to say 4 goes into 8 twice, 4 goes into 25 times, and now I have a much smaller number to multiply and deal with. When I multiply 5 times 35, I end up with 175 over 1 times 2, which is 2. And now for purposes of writing this in something that we can really think about as real life, go ahead and convert that to a mixed number. 2 goes into 17 8 times with 1 left over. 2 goes into 15 7 times with 1 left over out of your 2. If you've learned how to do that, you can. Otherwise, you go set up long division there. Okay, this is not considered right at this point because you need to label it. So you would actually say the size of the space bar would be 87.5 inches long. Go ahead and copy down example 3. Once you're done copying it down, hit play and we'll walk through it. Alright, so here what you want to do is you want to be looking for important things. So you're borrowing money, which is important because you know that means it's going to be basically a subtraction. To buy a lawnmower, and the lawnmower costs $245. you charge 18 to mow a lawn. So that's important. Write a rule to describe your profit, P of N, as a function of the number of lawns mowed, N. So that's important to know that that's based on your lawns mowed. When you go to set this up, you're going to start with P of N. My profit is based on my number of lawns mowed. And now I'm going to figure out how I'm going to make a profit. So first thing I want to look at is how much am I charging per lawn. And it's $18 for every lawn. So I get 18 times the number of lawns I mow. But I have an initial cost that's going to take away from my profits at first. And right there you have to think about subtracting your initial cost, which is $245. So this becomes your profit. This becomes your initial cost that was taken away. But once you pay that off, now you're going to have a profit from that point on. And then from here they might ask you to say, find how many lawns before you break even. So then you would set it to 245 here. There's different things you can do with these now. They might ask you how much profit you're going to have after 20 lawns, after 10 lawns, and you would figure it out. There's going to be a point where you're in the negative. Until you've paid off that 245, then you'll be in the positive. So again, we'll work on these more tomorrow in class and get some practice at setting them up.